Okay, so in the previous video I showed you how to put a quadratic in vertex form. I'm going to show you how to do it another way. Just don't really think you need to know two ways. I don't have a good reason why, other than knowing how to complete the square will be good for when you learn how to like graph ellipses and hyperbola and circles in pre-calculus. But anyway, here's another way how to put a quadratic in vertex form. So we're going to complete the square, and that's basically it. So what I'm going to do first is factor out a -1 in kind of a weird way. So what do I mean by that? I'm going to factor out a -1 only in the first two terms. Okay, so it's going to look like this. I'm going to leave the -8 right there. Okay? So I just factor out my leading coefficient so that I can complete the square. Now I'm going to complete the square. So I want to add a number right here that would make this a perfect square trinomial. Something that factors nicely. Okay? And that number is always going to be, and by nicely I mean a perfect square trinomial factors to like the same binomial times itself, because then it's in vertex form. Okay, so that number that I need to add there in that box is always going to be half of b squared. So it's going to be 9. Okay, so if I put a 9 there, I know that this part is going to factor to x minus 3 squared. And I got my leading coefficient. And I can't just add numbers randomly, right? It's got to be an equivalent equation. So you got to undo what you just did. Now by adding a 9 right here, okay, it's actually like I added a -9 because it's 9 times -1. So it's like I already subtracted 9 from the right side of g of x. So to balance it out, I have to add 9, and now everything's taken care of. So now it's like I added 0. Okay, so that makes our vertical shift 1. Alright, and there is our vertex form. Okay, it's a little messy, but it would be g of x is equal to -x minus 3 squared plus 1. Alright, and if you don't believe me, you can check it using the method we used in the other video. Take half of b, which was 3, square it. Oops, I lied, not that. Take opposite of b and put it over 2a, and we get positive 3. So positive 3 is the x-coordinate of our vertex. Okay, and then if we plug 3 in to our function, this would all equal, so it would be -9 plus 18 minus 8. That would equal positive 1, which was our vertical shift. Okay, so now let's sketch a graph of that. Okay, so I just cleaned up my space a little bit, so I got -x minus 3 squared plus 1. So I'm going to start off by finding my vertex, which would be at 3, 1. Okay, and I know it's going to face down, and I know that's going to have a y-intercept of -8, because if you plug in 0 for x, you get y is -8. Okay, so there's half of our parabola at 0, -8. Now the other half of the parabola is going to be symmetric about this line, this axis of symmetry, which means if I have a point 0, -8, I know there's going to be another point reflected over that line, which would be here at 6, -8. So it's reflected over a vertical line, so it doesn't change y-coordinate. And if I have to move 3 to the right to get to the axis of symmetry, I got to move 3 more to get to that point. Alright, and now we just complete the other part of the graph through that point, and there is our parabola. And we got 3 points, so it's accurate. It's a good width, it's facing down. So there you go.